Hello, Professor. Welcome to the walkthrough of the ColabD. In this session, we move beyond the standard PyTorch to use PyTorch Lightning. We begin by installing the library and importing the core modules. We use PLC the everything 42 to ensure that data splits and weight initializations are perfectly reproducible across every run. So this is what we have done in the first cell. Moving towards the second cell, we will generate our synthetic data set from the same three variable nonlinear equation from our previous collabs ABC. We'll combine x1, x2 and x3 into an input matrix and compute a target y before converting everything into PyTorch tensors. So we are using y, x1, x2, x3 to create y, and then we are converting them to PyTorch tensors. Once that is done, we will do modular data and model design. So one of the key benefits of lightning is the data module. Here we define a regression data module that encapsulates all our data logic. It handles the 80-20 train validation split and automatically creates a data loaders for us, keeping our main training code clean and organized. So that's why we are using PyTorch Lightning. Now we are defining our model using a lightning module. This class doesn't just hold the architecture, it also defines the training and validation steps. We implemented in our three-layer architecture with ReLU and 10H activations, specifically MAC loss, and configure our ADAM optimizer in all in one place. So we can see it has defined the forward pass, it has defined the training steps, validation step, and the optimizer, all things at a single place. Once that is done, instead of writing manual loop, we will use pl.trainer. We configure it for 100 epochs and specify that we want to run it on a single device. The trainer automatically handles the progress bar, logging, and hardware acceleration for us. So that's how we will do it. Once that is done, now we will start the training process by calling trainer.fit. So lightning takes over from here, iterating through epochs, calculating gradients, updating weights. You can see the progress bar tracking the training and validation loss in the real time. So you can see it shows tracking the loss and validations at the real time. Once the training is completed, we switch to evaluation mode to test the model on our validation set. Our results are outstanding. We have achieved a R square of 9.0.99 per, and a very low mean absolute error, proving that model has successfully mastered on non-linear relationship. So now let's visualize the results. We plot the prediction versus actual values for our validation set. Notice how tightly the purple points clusters around the red dashed line. So the perfect prediction line. This is a clear visual indicator of a high performing model. It is almost perfect. So once that is done, to conclude the implementation highlights of benefits of PyTorch Lightning, we have a cleaner code, automatic logging, less boilerplate and boilerplate, and then compared to standard PyTorch, we have successfully completed all the assignment requirement with a modern production ready framework. So all the tasks are completed for this part of the assignment. Thank you so much.